The left max and right max are a bit similar problems from different directions. To solve the left max problem, you need to think in a very similar recursive way to what we did already before. Let's compute the left max of my current list, and after that we try to maximize with it. I think this is very similar to what we did before. So here we have all of this list of numbers. We start by computing the left max of all of this list, which is going to be this bunch of numbers, and then I'm going to maximize between the last element from the returned list and my current element, which is going to be 7. As you see, we do not make any further tracing if we follow the what, not the how. This one is going to compute my left max. I'm going to take its last element comparing to my current element, append the new value, and that's it. In the right max, we follow a very similar logic. I am at a position, and then given that the right max, then we focus. So the left max is focusing on the left side, but the right max is focusing on the right side. So we think from head of 0 here, or list of 0. So first of all, we go and take this list and compute its right max, which will be now all of these numbers. And once we are returned with that, we need to compare between my head of 0, which is my head of 0, which is this third element. I'm a list of 0. What is the max between 1 and 7 is 7. Now we would like to insert it in the first position in the list. So I hope the two styles are close, but they are from different angles, which are common, so it's good for you to know.